Welcome everybody again to another episode of the ideaXme show, the show that profiles the humans with the really big ideas that are shaping our world, inspiring future creators in the future. And for all those that like great stories, I'm Ira Pastor, your health and biotech ambassador along for this journey. So as many of you know on past shows, as we've been spending time navigating, as I refer to, the biological architecture of life, we primarily spend our time talking about the human body and the human organism. Today, however, we are going to journey a little further into the area of actual architecture. We are joined by Professor Rachel Armstrong, who is Professor of Experimental Architecture at the School of Architecture, Planning and Landscape at Newcastle University. Professor Armstrong completed her PhD at the Bartlett School of Architecture, and while conducting experimental work at University of Southern Denmark, first explored the concept of living architecture, which involved delving deeper into the possibilities that metabolisms from the natural world could ultimately be translated into a more sustainable form of architectural practice. And her current work focuses on establishing various conditions for these living architectures, which basically couple the computational properties of the natural world with building structures and infrastructures. In addition to her being director and founder of the Experimental Architecture Group, whose work is published, exhibited, performed in a variety of different international venues, she's also the coordinator for Living Architecture Project, which is an ongoing collaboration of experts from various universities in the UK, Spain, Italy, Austria, which has been focusing on integrating fascinating next-generation bioreactor systems that can ultimately work synergistically with these novel architectures to potentially do things like clean our wastewater, generate oxygen, provide electrical power, create usable forms of biomass, ultimately, in essence, recreating sort of this bidirectional flow where the architecture not only takes resources from our environment, but ultimately gives back. Professor Armstrong is widely published in both academic and popular press. She's written a number of academic books, including Liquid Life on Nonlinear Materiality, Soft Living Architecture, an Alternative View on Bioinformed Practice, Star Arc, A Living Self-Sustaining Spaceship, Vibrant Architecture, Matter as a Co-Designer of Living Structures, as well as some fiction, including Invisible Ecologies and Origami. Professor Armstrong, thank you for taking the time out of your Sunday to come on the show.
Thank you for your invitation and for such an incredible summary of what is really a diverse set of practices kind of converging on this idea of living architecture. So thank you.
So it's an honor having you. I'd like to start out, as we do on the show, by basically giving you the floor for a little bit, just to talk about yourself, your background, how you developed this interest in nature, a love for nature, really, a love for science, sort of going back to that, as you've done some of your TED Talks, that time early in life where you and your sister would collect the creepy crawlies and try to create these sustainable bioreactors and jam jars and so forth, and how you've gotten to the epicenter of this truly fascinating domain of merging life sciences, architecture, sustainable living. Take the floor and introduce us to you from this angle.
The ideas really have been with me since I was a little girl, as you said, out in the back garden, looking at the vibrancy of the living world. I mean, I think like many kids, absolutely captivated by creepy crawlies, that things weren't static. Soil was turned over and things happened. Details in the trees of spiders and wasps, and the things that hid under stones were, an absolute treasure to me. And I think that idea of a vibrant, living, non-static world was really the thing that captivated me as a child, the thing that I then studied, when I was at school. I absolutely loved biology, read science fiction as a way of, I guess, thinking through the ideas in science and seeing how they could be applied. And so, influences like John Wyndham, for example, and Douglas Adams. I loved the playful use of language. So a kind of melting pot of real biology and these ideas of the possibilities of taking the narratives that, maybe as a child, out into the world and seeing what one could do with those. And then when I went to university, the whole of the science education was incredibly formalized. So I was at Cambridge as an undergraduate doing medicine. And the reason it was medicine, say, rather than life sciences, was because I wanted to apply science in a way. And it was really medicine as an implied forum through which I could design with biology became possible. And so this was the age before synthetic biology happened. So that there wasn't the idea that you could actually manipulate the biological substance itself. That, as Richard Lewontin would say, it was the just so stories of biology. Rabbits had a particular form because they had a specific need, and therefore, inevitably, the rabbit was a rabbit. But as I then went through medicine, I was looking at how the human body could be transformed by the scientific knowledge. And it was really in my final year, actually, I went to Oxford after my undergraduate, where I studied, I did the FAST course. I did my undergraduate studies in 2 years, and in the third year I was allowed to do like a mini master's, like in a year. And I worked with Rob White in genetics.
Okay.
And I was in this amazing building where there was all kinds of scientific research going on, from development in mouse embryos to neurological research. And so it was, the field of developmental biology became very present to me, and I got absolutely obsessed. I was reading Cell down in the library every time I kind of got a break, and then went straight back up into dissecting out my little fruit flies and trying to figure out where the gene expression was. And so that was a world I absolutely loved. And I was thinking, oh, medicine's going to be more like this. And then I went to Oxford and started to do the clinical training. And it was nothing like the scientific world that I'd fallen in love with. And so I had to kind of come up against the social impacts of, let's call it, natural biological processes and the possibilities that technology could bring when people could no longer function or kind of felt whole in a particular way.
Sure.
And it became very apparent in India. So I went on a sabbatical to Pune, and there was a leprosy colony there. And I went out with a registrar, and he was a hand surgeon, and we were doing very simple operations in this amazing community that had literally beaten the ground into fertility, so that because they were outcast by their own families and by the community, they actually made a life for themselves. And this absolutely fascinated me, because even though we could restore parts of the body by transplanting tendons from, let's say, the masseter muscle, so the chewing muscle, split it and thread it either side of the eye, so that when people lost the blink reflex through the nerve damage caused by leprosy, if you gave them chewing gum, every time they chewed, they would moisten their eyes, so it prevented them getting blind for a while. And then the other one was to split the non-dominant tendons from the fingers and thread them into the thumb, so that people could actually have grip. Now, you could do that in the middle of nowhere, as it were, because when people have affected nerves, they can't feel anything. So you can conduct surgery without anesthetic. And so this was, again, a kind of a marvelous insight into not just the anatomy of the human body, which I've been training towards, but actually then how people configured their lives around small changes in the way that they lived. So with these small interventions, people then used vats. They were like communal vats of wax that they put their hands into to keep the skin supple, so that they didn't get contractures in these newly operated parts of their bodies. And so there was like a whole kind of social organization around differently abled bodies. And one of the things that I started to notice was that the mechanical advantages of their machines were very different. so that you could operate a pair of pliers with your little finger if necessary. So with huge mechanical advantages, they could make electronics, which then could be traded with the city, and even internationally. So they became self-sufficient. Also, when even in domestic tasks, cooking pan handles were a good yard long, sort of 70, 80 centimeters or so, and it meant that they didn't get too close to the hot plates, and so they didn't accidentally burn themselves because they just can't, feel the heat.
Right.
So seeing the way that people could reconfigure space, technology, the body, and through their commitment to each other, and in re-engagement with the nature that they were in, they could figure out a life with themselves that wouldn't be one we would recognize through the utensils and the customs that they held, but really kind of worked for them. And I just started to see that it wasn't just about the function of the human body.
Right.
There were all these other layers around our existence that actually helped us situate our lives within a particular context, and that the houses that I went back to, the kind of environment that I went back to in a Western society, had a very particular character. And I started to realize just how we were constrained by the way that our buildings and spaces were designed, and how very dead they were. That the question became really, why do we as living things inhabit very dead spaces through which all our activities of daily life in some ways transform into a dynamic space? And particularly with the issues of climate change and the way that we treat waste and the natural cycles that go on out in the natural world, these aren't really taking place in an environmentally reconstituting way in the very acts of daily living that we participate in. And given that in India, I saw how very small changes like, rethreading one tendon from a finger to a thumb can transform a life.
Sure.
And make them, let's say, be able to conduct work that brings them an income that allows them to support their family. Could small changes in our homes and the details of how we live actually make much larger impacts on environment, but also on our well-being too? And I think for me, the question was then, if this is the case, then what is the unit of design for a more vibrant or living architecture? I mean, where do we start? Do we start with concrete blocks, or traditionally bricks, clays that, let's think of it in the origins of life context, are actually dynamic chemical spaces that enable organic molecules to come together in orchestrated ways.
Sure.
And we transform that substance into something that's inert and impermeable, and it becomes like a shell. Can we keep that dynamic vibrancy of the clay, as it were, alive or dynamic in its natural context within the way that we select the materials that are most proximate to us, so that rather than living inside a dead thing, actually our spaces that we inhabit actually have a metabolism just like us? And I think the work that's been forthcoming now since 2007, when this idea of the microbiome started to enter into public conversation, and that the idea that if we can actually look at the microbial realms around us, actually we don't just live in sterile homes, which is the conventions of modernity. So Le Corbusier, he in Villa, I think it's Savoy. I'll just double check that actually. I'll start that little bit again. But let me just
take your time.
Yeah. Yeah, I think it is Villa Savoy. Yeah, it is Villa Savoy. So I just wanted to check it because so if we think about the modern cultural conditions of architecture in relationship to the microbial realm, that we still inhabit an age of hygiene. And classically, Le Corbusier in Villa Savoy had a basin, a sink, in the ground floor of his exemplary modern building, as a way of demonstrating that cleanliness was part of modernity. And so the age of hygiene is still with us in the design of buildings. And so we don't really appreciate the possibility of a microbiome, right, because, you know, our spaces are dead and they're clean, and you know, sinks and bathrooms are really temples to purity. And I think in 2007, you know, this idea of a living architecture actually became, you know, much more real in the context that our buildings, whether we like them to be or not, are actually, you know, humming with ecologies, right, you know, that are perpetuated by our activities of daily life, except that we are designing those spaces in a way that's ignorant or kind of unaccepting of the fact that, you know, our bodies are teeming with microbes. And so the question becomes that if we can actually think of living architectures that embrace the presence of microbes, don't try to throw Dettol on them and sanitize everything. Obviously, patterns of good health are also balanced with, you know, the microbiomes that are in spaces and pathogens, you know, which are less than 1% of all microbes anyway. But finding a healthy balance between the bacteria that our bodies need to function, which is what we've discovered since 2007, right, and kind of maintaining good health, I think is, you know, one of those things that I think is really pressing for architecture, because in modern lives we spend 90% of our lives indoors. And 90% of those lives are spent redistributing our interior microbiomes with the microbiome of the built environment. And the question becomes really, you know, how do we start to design with that? I mean, what should we or could we do with that? How might we actually work with the idea that bacteria are present in our buildings? In fact, I'd say that the only part that modernity didn't really reach is actually beyond the plug in your bathroom sink and shower and kitchen, because, you know, those places are thick with biofilms. And, you know, we've got lots of products to get rid of those, but actually if biofilms are actually part of the ecology within an interior environment, you know, can we ask those to do interesting work? So the kind of building block I was looking for was this idea of a unit of design that could actually metabolize, that had some characteristics of a living thing, but may not necessarily be alive. And I think at the time there was this question of the idea of minimal life. So as J. Craig Venter and the synthetic biologist were trying to sequence the human genome and gain knowledge from the understanding of that process, this idea of what the minimal components of what we would call life would be was actually one of those things that started to inform my thinking. And it coincided with me going to this you know, Artificial Life 11 conference down in Winchester and coming across a presentation by Takashi Ikegami and then by Martin Hanzuk of the Proto cell. And what I saw from Ikegami's presentation was this oil droplet in an alkaline environment that was literally shedding the skin like an amniotic sac. Sure. And the vigor through which this droplet shed that coating just looked so lifelike. And I was thinking, hang on, that's got no genes, and yet it has the kind of dynamism and the pattern making and the work producing qualities that maybe a unit of design for architecture could embody. Mm-hmm. Because there's an ethical question that comes into play when you start thinking about things that are living. There's also a political question. There's an so the ethics of, is it appropriate to use something that is called life in relationship to ourselves, as to whether, this is the right kind of thing that we should be doing. So the idea of a non or a semi-living unit was very interesting, because it allowed me to interrogate it in a way that enabled me to start from the beginning in terms of all these questions about, what constitutes life, right. What are the ethical conditions? What are the reciprocal agreements between the unit and the person that is using it that need to come into play in order for this to be something that we can really start to work with in a creative but also very responsible manner. Right. So it was really trying to figure out how we actually set up a contract of exchange between a semi-living or a kind of dynamic object and the person that is kind of situating that object in a condition of mutually productive work. Right. And it was really important to have that framework, rather than just saying, is this a technology that I can exploit? Because I think that very consciously, once we start to engage with the living world, that we do have a responsibility and a relationship with it, and how we configure that really is at the basis of the way that we start to shape our lives. So that if we don't see the world as being living and dynamic with full of creepy crawlies in it that are affected by us throwing pollutants into the atmosphere, if we don't see that, then there's no ethical consideration. But if, like, when I was a kid, I saw the vibrancy of the world, and I was absolutely enchanted by it. And so that was, I guess, the point for not just thinking through exploitation and not just thinking through points of efficiency, but actually engaging with the care, the ethics, and the reciprocity between the unit that I'm working with and what it is through design that I'm trying to ask, interrogate, achieve. So the first unit then that I was working with was the Proto cell, and that was a form of minimal life. So, J. Craig Venter and synthetic biologists are trying to figure out how few genes we can get away with in order to create something that is autopoietic, essentially. Sure. And so the question with the Proto cell was not really about its autopoiesis or its life, kind of mimicking life as such. It's which of those properties were useful in this context of taking care of things. And the question then of metabolism rather than genetics became very present. The idea if we could set up a metabolism, in other words, a persistent form of chemical or a substance-based exchange between your designer and the agent, then actually that's a relationship that can be sustained. And there is a kind of mutuality within that, because if I don't provide the unit with the things that it needs, it stops being the dynamic body that I want it to be. And so it really kind of ties the person with their technology or the materials that they're working with. And so anyway, the idea was to first of all interrogate this in an environment, in a laboratory environment. So that was the work that I did at the Southern University of Denmark with Stine Rasmussen's group, and Martin Hanzek was working within that. And that was a really amazing environment, because they were all interrogating these questions of minimal life. They were looking at this question of living technology. And they also had a group that was working with them, which was called the ISSP, which was the it was about social and political dimensions of the impacts of the living technologies. So they were already thinking into those dimensions, and it was an absolutely incredible environment to be in, because it wasn't just about the technology, it was about the social and environmental responsibilities as well. So that was a great place to be working. And the other thing was that the legacy of the protocell had actually got some history in the city of Venice, in the European Centre for Living Technology, which had been set up by Norman Packard and Steen Rasmussen and other partners. And they were looking at highly complex chemistries and materials as their focus. And so I went to explore experiments in the European Centre for Living Technology, and realised that the whole context of Venice was a wonderful place for thinking through the protocell as a unit for design in a real environment, as it were, a real challenge to ask of a highly experimental, highly conjectural kind of dynamic chemistry. So being in Venice and then thinking through the protocell as part of the lagoon ecology was really fundamental to this whole idea of future Venice. That thinking about the challenges that Venice is facing with the efflorescence and the incursion of water into the building materials, which when they are static is destructive.
Right.
But if we look beneath the tide line in Venice, we actually see a rich ecology of mineralizing lagoon ecologies, such as shellfish, calcium-producing algae, and bacteria. So already the lagoon itself has got an informal kind of architecture. Think of it like being scars that the city is producing at this tidal zone. As the waters have risen over the Istrian marble, which is like it's like an impermeable barrier. But once that gets breached, all the water goes up into the brickwork. So the idea then was perhaps the protocell could help with this strategic repair of kind of built systems. So inert materials, could it create like a healing surface that would be able to, for example, wrap itself around like a reef the foundations of Venice.
Sure.
So those are made of wood piles, and with the the Grand Navy, the big boats that go through the lagoon, you get this lowering of the water line with the wake. It exposes the wood piles to air. The microbes come in and chew on the woods, and it starts to create rot in the system. So the idea was, potentially, could the protocell, together with these what we call biofouling, actually create this scar that might help stabilize Venice's foundations. And so that was really part thought experiment, part laboratory explorations, and also a wonderful experiment that we did on the side of the lagoon in Venice, in big tanks, taking the lagoon water and actually looking at how the mineralizing protocell bodies could actually generate a calcium-like structure. We did that with Red Bull and some of the Venetian architecture students at the time. So we couldn't actually go into, so Venice's water is actually, very mucky, and you can't see very far in it. But by bringing up the water into tanks, we could actually see how this process might work. And so really at the moment, that the technology is nowhere near advanced enough to even, propose this as a solution to a UNESCO World Heritage Site. But what it did do for me, I think, was to start to really interrogate this idea of using metabolism and using dynamic chemical exchange as the basis for inhabitation. And what was nice about Venice was we started to see that actually the non-human world was creating architecture too.
Sure.
And that was actually already in conversation with the human inhabitants of Venice, responding to all the minerals that we're throwing into the lagoon through the industrial plants on the mainland, and the detritus that comes in through the Gatterley, the sewers, and that that the non-human world is actually responding to our presence. And so there was a kind of informal architecture that was co-produced by non-human and human, and has been that way for a millennium. And so this meant that for me, okay, I wasn't actually generating a building as such, but the principles for a form of architecture, a form of design that was a collaboration between people and the living world was actually not just conjecture, it was actually possible. And so taking those ideas then, and then figuring out how we could actually do that in a more everyday way, because Venice has a very unique, and wonderful site, in the Po Delta, and in the Venetian lagoon, so where it's protected from the Adriatic Sea by a set of barrier islands, and so it really has a very kind of unique geography and what we would call it an ecological niche.
Sure.
But how could we actually take some of those principles and think about that in kind of more modern context, in more land-based architectures, but also appreciating that most of our cities are built around fertile waterways, built around deltas, built around rivers that provide this flow of nutrients, which were necessary originally for farming, and now I think they've become more aestheticized and more like public spaces, and all our utilities have kind of disappeared into the infrastructure of buildings. So what if our infrastructures of buildings were actually more like nature than simply pipes that are just delivering resource? And so, again, inspired by the Venetian lagoon, could we actually look at the microorganisms that were creating all this work, producing all these kind of materials? So some of those would be soluble, some were insoluble. Could we actually harness that work in some way within the context of modern environments? And so this idea that actually working with infrastructure first came to mind, because the conditions through which living things can exchange materials that sustain them and make them dynamic is dependent on infrastructure, it's dependent on flow. And if we look again at Le Corbusier's Villa Savoy, everything is designed in a way that is anti-life, anti-flow. The greatest thing that moves through Villa Savoy is a car. So, can we reconfigure our ways of living so that they can reaccommodate nature, not just in a decorative way, but actually in a way that preserves the functions that nature performs outside of a building interior? So microorganisms were again placed within that context, and the Living Architecture project, which was funded by the EU Horizon 2020 FET Open system of awards, came about. And that was to appreciate that the Proto cell itself was something that didn't have a sophisticated enough metabolism in order to perform the kinds of work that would be useful in a building interior, and to actually then look to the realm of bacteria and other microorganisms to perform this, particularly looking at the role of synthetic biology in helping us specifically achieve and program particular tasks. So the question became, how might we actually start to garden and program the outcomes of microorganisms in a space that we co-inhabit in ways that, first of all, are publicly acceptable in an age of hygiene, but also are meaningful to the bacteria or the microorganisms who need a particular set of conditions to live. And so, and flourish and build their own little cities.
Right.
So working with Spanish National Research Council, Martin Hanser from the University of Trento, Yanis Aropoulos from the University of West of England, Barbara Imhoff and her team from Liquid Systems Group in Vienna, and Davide De Lucretia from Explorer Biotech in Italy, in Venice. We set out to try and figure out what this actually meant. And so we developed a set of bioreactors, each of which had a different function, but was put in conversation with a bioreactor next door, which had a different metabolism. And so I'd say the breakthrough really was not just being able to design an environment as a bioreactor for a particular set of microorganisms, which has already been done with the microbial fuel cell, which is the specialty of Yanis Aropoulos, but actually to start to sequence these so that metabolites from one bioreactor fed into the metabolisms of the bioreactor next door. And so taking the anaerobic microbial fuel cell and juxtaposing that with the photosynthetic algae bioreactors, we started to synergize the metabolism so that we could boost the power of the microbial fuel cell with a provision of oxygen as an end acceptor of electrons, terminal acceptor of electrons, and therefore, kind of really make the electrical power stronger. That was our first move, to bring together photosynthetic and anaerobic environments through an interface. And then the second move was really then to design a completely synthetic bioreactor, which actually was a unique world in itself. It was based on the microbial fuel cell, where the anode was a photosynthetic environment that had it didn't produce, I say anode in the sense that the environment was split into two. So we called it a farm and a labour module. The labour module didn't need light, and the farm module did. That housed an algae that was modified to overproduce sugar. It then passed through the membrane, that would be the equivalent of the microbial fuel cell, and went into then the anaerobic environment of the labour module, where we had a bunch of workhorse organisms. Now, the good thing about that was that we knew their genes and we could hack them. And what we found was that in this carbon-rich environment with loads of sugar, that not only could we ask the individual workhorses to make a product that they didn't normally make, for example, to clean phosphate, but actually we could design the metabolism across the different workhorse organisms. So E. coli had a set of apparatuses that Pseudomonas didn't. So we could actually consider that as a kind of superorganism, and we could design a metabolism that worked across both species. And they would do that when they were in a carbon-rich environment. And so in some ways, that was also an environmental control, because if the modified organism left the sugary broth, then it wouldn't continue to exploit its synthetic gene. So this was very interesting. We started to show that not only could we juxtapose different kinds of natural metabolisms, but that actually we started to synthesize new kinds of metabolisms that didn't exist in nature. And so this was imagined as, let's say, ideal homes for microbes. So we're building the homes for microbes before we build the homes for a person. And with this then, it starts to really intersect with this idea I mentioned earlier, which was the microbiome of the built environment. And I think that that's the interface that I'd really like to explore. We're not there yet. So we've created the living architecture infrastructure. We proved successfully that these metabolisms could be designed to perform the kinds of housework that we imagined that they would do. So traditionally, housework has been done by mainly women, and it's normally about cleaning and the kind of age of hygiene and preparation of food. And I really like this idea that housework can be done by non-human bacteria, and that kind of housework is cleaning your water, producing electricity, generating compost for growing vegetables, all kinds of things that we would not normally consider to be housework. We might possibly consider them to be agricultural practices or gardening practices. So this idea now of kind of sharing the work of the home with the non-human world actually starts to invite them into our lives, not just as pets, as it were, but actually as symbionts, that might be necessary, particularly in an environmentally strained world, for healthy living. So one of the other things that the living architecture synthetic metabolism could do was also remove nitrous gases, so nitrogen monoxide. So all of those gases, the pollutants, could be metabolized by the bacteria. And we know that indoor air pollution is a real problem. So the idea that you've kind of got this functioning, designed, in inverted commas, body that is made up of these different sequences of microbial metabolisms is actually something that lives in your home, that you look after, but is actually doing useful things for you. And so by taking care of that body, you're taking care of your own body. So it's kind of a hygiene, but it's not the age of hygiene, which is to get rid of all bacteria that you can detect. So it's a very interesting scenario, because then the question becomes, okay, so we have these co-inhabitants of our spaces that we have invited in, and we've provided space for them in these bioreactors. So then what does a healthy microbiome look like? Because our microbiomes are informed by our bodies, and that kind of interface between the exterior and interior of these apparatuses, I think, is a very interesting one. Can we actually, through our ablutions, so that our interior microbiomes are going to be going into these bioreactor systems, because the Living Architecture project was metabolizing grey water and urine, so that some of our microbiome will be entering into these environments, so that in some ways we would be seeding the natural biofilms.
Absolutely.
And so this is very interesting, because we would then be exteriorizing our internal microbiomes, and this becomes a monitor potentially for health, not just environmental health, but maybe even bodily health as well. So it's a very interesting concept, that once we start to acknowledge the presence of these invisible agents, and that once we accept that they're there and that we take care of them, we can find other ways to take care of ourselves, as well as the environment. So this is where the Living Architecture project is at the moment. And I will, because I'm submitting the application form very soon, also say that we are trying to scale this up. So the Living Architecture project has an individual household in mind.
Okay.
And although I would say it's still very much at a kind of low TRL, call it 1, 2, 3, depending on what you're asking it to do, the idea of actually scaling that so it can actually manage household waste and generate an environment for a 12-volt system. So it's raising questions about whether we need 230 volts. Certainly in the EU, there's a 230-volt supply in every home. Can we think of lifestyles that can be based on 12-volt systems? And what do we need to do differently if that's the case? Because that 12-volt system can be provided by the metabolism of your waste. You don't need fossil fuels.
Right.
Ideally, I mean, so obviously, in the kind of the commercial world and the marketplace, there are all kinds of pressures that would create a suboptimal situation for uptake of these technologies or uptake of the 12-volt home idea. But it's definitely possible. And right. I think through good design and teamwork, I think that we can really reconfigure the ways that we do our everyday things, the things that we do most unconsciously, through this idea of a 12-volt system. And if that was carbon-free electricity, that becomes really interesting. And if we use the heat produced by the decomposition of organic waste as the heating system, I think we can really reconfigure the expectations of the way we live, and that our household management is actually something that flows through our bodies and the resources that we consume, so that consuming is not a bad thing, because it's not just a one-way street. As we consume, we're also producing substances that can be then reused by microbes. And those substances are reused by microbes, but they're done in sewers and places that are away from the places that we live. And so there's no gardening of that. There's no kind of ability for the individual to be able to see how their daily lives are enlivening the environment or harming it. Right. So we've got no feedback as to how well our existence fits in with the natural world. We have to rely on statistics and what we're told, and scientific evidence and things like that. But being able to see that in a very tangible way through how much power we're getting out of the house, or how much clean water we've got, or the kind of the joyful bubbles that are going through the microbial bioprocesses. Those are very tangible things for us to be able to get a reading of what kind of ecological being we are in the world. And so what we're trying to do is actually think about how some of these principles can be scaled up to the urban context. And the obvious place for this is actually rethinking the sewage system. I mean, these are not attractive architectural agendas. I mean, really, the age of hygiene is so steeped in modern practices that the idea of waste is not really palatable, not to a conventional expression of modern design. So, in some ways, thinking about wastewater, thinking about sewage, thinking about the dirt, those thick biofilms that are beyond the reach of modernity is a kind of design heresy, which is exactly why I think it's exciting. Right. And so if we rethink how we actually treat our wastes and actually start to call them out as technologies and processes and things that we can relate to, we actually start to socialize these ideas in ways where we can start to discuss and figure out in communities of how we might actually deal with waste and even benefit from it. So the proposal that we just made is working with a wonderful company called Organica Inc. or Organica Water Inc. And they make wastewater gardens. And they've been making these wastewater gardens for the last 25 years. Right. Many of them are in the Far East, but there are a couple of sites in Europe, in France and in Hungary, where essentially wastewater, including sewage, from domestic supplies goes into primary treatment, settlement and sedimentation, and then goes into a series of tanks which have root microbiomes from plants that treat the organic matter. So there's some aerobic tanks and then there's some anaerobic tanks. And what we're trying to do is situate microbial fuel cells in those environments so that we can actually generate electricity. And again, this would be low power electricity. We don't know how much we're going to be able to produce. Maybe this is not an experiment that works particularly well. Maybe it's something that just enables lighting to take place within the wastewater garden. But again, we're trying to bring together different metabolic worlds to perform tasks that might be useful to us. And so we bring together experts in design and architects and urban planners together with city councils and technologists that are able to start taking steps towards this. So just imagine if your community was actually, the street lighting was powered by your sewage, and that actually made a lovely greenhouse garden experience. You could make a winter garden, so some of it would be undercover, some of it might be out in the open, particularly in the aerobic environments, depending on where you are, in terms of your, latitude, so that there are different requirements for each of these different metabolisms, different speeds at which they work, and so that in some ways every city would have a different set of parameters through which to think through this kind of design. And so I just want to say that these ideas are not just science fiction, they're actually starting to make their way out into the world, that the infrastructures for these kinds of thinkings already exist. So as I say, Organica Water Inc. is a real company. Mm-hmm. And it's got international outlets. And so these forms of use of our waste are real, and they can service, let's say, populations of, at the moment, I think 30,000. So that these are real community resources. So going from the individual home and how we might actually use waste, and then thinking about maybe if we're thinking a different kind of scale of economics, or if our value systems are different, then maybe it makes more sense to do this out in the community. But what we're trying to do ultimately is to wean ourselves off fossil fuels. Right. And so it won't be an overnight coup, as it were. What we really are trying to catalyze is an age of low power electronics, because if we can get computer servers to run off 12 volts that are provided by wastewater, we've got a real capacity to link the metabolic and biological and sustainable and organic with the smart. Mm-hmm. And then that becomes a really interesting place for design, where people working from kind of all kinds of disciplines can come together to reconfigure, what do we need to live? And that's the kind of Zoe, the bare life. And then what do we need to live well? And how much extra resource do we need in order to live well? And I think that these are really important principles to think about, because I don't think this is just about hair shirt living. This is not just stripping things back to basics so that we, have a very simple and uncomplicated life. This is about creating a different kind of richness, and thinking about what is important to us, and then socializing and kind of creating a cultural environment that enables that to be sustained. And so that maybe in a community like this, profit isn't the most important thing that drives a thriving community. Maybe the thing is a healthy metabolism, where different kinds of wastes are used and reappropriated in different ways by different people, so that it's not just a homogeneous form of consumption and producing all the same kinds of wastes, but actually different people are producing different kinds of wastes, which in some ways, and maybe not in the economic sense that we're used to, but they become tradable. And so that there is a kind of a parallel form of economics that coexists with these ways of going about our lives differently. So I would hope that if we involve design and culture in the evolution of these technologies, and wrestling with, how we actually implement these in the real world, and what this means for people, then hopefully we can get, sustainable paradigms that allow people to go, well, I actually prefer doing it like this, because I know I can see a garden growing. I know that the old people's home is well lit. I know that the school kids love going out to those toilets and peeing and seeing, kind of little electronic screens go on that tell them about the health of their community in environmental terms. And actually, I like this way of living. And so really, we want to get to a stage where it's a preference, not an obligation, and not a kind of puritanical form of hair shirt, kind of cutting back and doing without and making do. I think that there's a complex psychology in this, And I think we're only at the very beginning of this journey. And as I said, that even though my imagination is greatly shaped by science fiction and the possibilities that don't quite exist yet, I think with and when I say we, I mean I've worked with incredible collaborators. I mean really incredibly skilled, insightful, talented people, and kind of being in a rich community like that really makes things possible when as an individual you think the idea, but you don't know if it really works. Right. And then when you work in a team, and I particularly love the international kind of intercultural exchange. So when you're thinking along with people from Italy and Austria and Spain, your own assumptions about the kinds of things that you've learned and the kinds of things that you do are also challenged. So, I'm giving a big shout out to European communities and also, transatlantic exchanges as well. Sure. Because I think the more that we can think together, the richer our solutions are going to be for what is an incredibly fragile time. Right. But I think within that are encoded real breakthroughs in the way that we think, engage, and remake our world. Right. And I am a diehard optimist, but I'm not an optimist without graft. So I think that by prototyping possibilities to Absolutely. Functionality, that the reprototyping, this is not about solutions. This is about reiterating our needs right. through a relationship with technology and environment, so that we find something that works. And it's not about one person's authorship about what, in inverted commas, the universal solution is. This is about people working through the challenges and opportunities in their own environments, their own resources, and being re-empowered in a time that is incredibly challenging and extremely worrying in terms of trying to imagine how we can turn things around.
I appreciate that introduction. You covered certain things I have on my list here, but I have other things I want to go
Great,
into.
Fantastic, yeah.
I'm sitting here and I'm thinking about, you talked, you said a few times it's early stage, but it's really, I take my hat off to you because really not. You've done so much, and then you look around the world, and obviously, I don't know if you can point to an example of where someone has created sort of the integrated system yet. But I look at things. I'm sitting here on this side of the Atlantic, and I remember thinking back about 20 years or so. There was a chicken processing facility that was doing something similar in the sense of the living machine, the small scale living machines for chicken processing wastewaters, anaerobic microbes, aerobic microbes, plants. I think it involves snails and fish and other things of this nature. Obviously, it wasn't potable water that came out the other end, but you could water a garden with that. It wasn't sludge. I think about the global seawater project from a few years ago in Djibouti, where I forget that cycle was salt water to shrimp, to mangroves, to salicornia, and so there are examples of where sort of this thinking, may not be perfect, it might not be completely integrated yet, but where we're starting to see it on a grander scale. Now, one thing I love about when I watch your presentations, and you talk about, and you like to use this word that, but there's sort of these moonshot thinking. You talk about land reclamation in Venice. You talk about atolls, big picture issues. There's a project that the Kingdom of Saudi Arabia is talking about. Setting up on the Red Sea for a small chunk of money, $500 billion, where they're going to build this city in the middle of nowhere. Futuristic city with biotech and all sorts of futuristic things. I'm going to throw this one at you because I like doing this because you're you're a moonshot thinker. And obviously think about the big stuff in your spare time as opposed to, what you're writing in the grants. But, if mysteriously that $500 billion or 500 billion pounds, what we'll call it post-Brexit, ended up in your bank account tomorrow, I'm sure you dream about the things that you would do with it in terms of this project and these types of projects. Take us out a little bit. If where is this going? I want to talk about the lab stuff is miraculous. It's beautiful, but what are the things that you would do with infinite resources at your disposal to make some of these big picture, city scale, atoll scale projects reality? I just take us on a little journey there, because I think it's
fantastic. I'm glad to have this opportunity. I mean, for me, the thing that we miss in urban design is actually the design of soils. And I think that when we think into the actual fabric of what it is that we're actually talking about, the reinvigorating the world, actually by reconstituting our soils and giving soil space within our cities as valued, let's give them the status of beings, because I do think that politics plays a big role in this. Sure. As you've just pointed out, that there are all kinds of solutions that could help re-enliven the world, except that the infrastructures and the vested interests in keeping us on fossil fuels and doing things in particular ways is creating a kind of paralysis. Right. And it's a paralysis with political power, which is why I think it goes back to cities and municipalities and mayors. In other words, I think our action is distributed. But the fabric that we're talking about is a reinvigoration of soils, and that was the basis of the Star Arc book that I wrote, which was that you cannot sustain any kind of community indefinitely without a material system of restructuring matter. And it is the living soils on our planet that do that. And, I am inspired by, the insights of Lynn Margulis in her contribution to the Gaia hypothesis, right. Kind of like when she and Lovelock are trying to address this NASA problem of how do we spot a world out in the vastness of space that may harbor life. Right. And the idea of the disequilibrium of the chemicals, so that oxidizing and reducing substances can coexist on a planet and don't just reach kind of equilibrium, is actually the thing that might possibly say that there is a dynamic metabolism on that planet that would equate potentially with life. And so Margulis put that dynamic metabolism in the realm of the microbes. She pointed out that when microbes metabolize, they actually produce the gases and substances of the world. Right. And that on the epic scales of life that we've had on this planet, 3.5 billion years, maybe more, that's enough time for that chemistry to get going. And the structuring of earth soils, I think, is one of, and the sediments of the deep. But the ones that we really benefit from as let's call them higher animals or complex animals are the earth soils. And we've looked after those traditionally through farming. And I think that there is a 21st century way of engaging with soils. We're starting to see it with people saying there are mycelia now that can break down plastics, or microbes that will break down plastics. And I think that we really have to think into that space. I think critically, we've got 3% of the earth at the moment, which is fertile soil. In other words, ones that doesn't need fertilizer. We've had loss of fertile soil because of the use of chemicals, which break down the structure of soil in order to fertilize it. So we've kind of gone into these, weird destructive practices that, it's like putting explosives on a field to fertilize it intuitively, is not an elegant solution. Obviously, it's worked to a point, but it's not sustainable. So I think if we can reconfigure the fabrics of life, and think about what are the pollutants in a city, and think about those membranes, the soils, which will help us filter and turn over the matter that needs to be processed within the way that we live. I think for me, that would be where I would place that. It wouldn't be in let's say a particular building. It would really be in infrastructure. If we don't sort out our replenishing of the infrastructures of life, we are in these kind of runaway points of escalation, these tipping points that are already seeing ecosystems collapse. So keeping it local within a city to try and figure out not just greening. It's not just greening. It's not just about the topsoil vegetation. It's about the kind of the deep processing systems that reconfigure matter. And you know what? If I had to start somewhere, it would be a garbage patch. Now, how could, we've got to get away from this idea that we just tip everything into a hole and it'll sort itself out. That we actually need to really think through the structuring of those systems.
Okay.
And so, yes, I would have a 21st century garbage tip. And I would get people together to think about how we use that matter to reconstitute the ground and turn it into not necessarily just a wilderness of, what we romantically think about being nature, but the new kinds of life and vigor that come from that. And that would include, how could we use that to generate the electricity to feed, smart systems, generate heat? How do we actually get into that space? So it's really not about an epic project. It is really, beneath the plug of your kitchen sink. How do we re-engage with that? How do we bring about a choreography of the incredible processing power that's here on this world? How do we actually get stuck into that? I think is our first step towards re-enlivening the planet.
Speaking a little further along those lines, you just reminded, when I do this show, I always introduce my three children to the guest ahead of time to see if they can come up with questions that I'm going to miss because I'm not as creative, or I don't have that sort of the children that appreciation for the small things that they might. But my daughter had a question for you, and it had to do. We were recently at Disney World, and there's a section of a ride at the Epcot land pavilion where they go through the desert, where they explain that the desert is not this dead, barren landscape, but beneath it, as you were just talking, has its own unique set of ecosystems that I can't speak intelligently about. But she wanted me to ask the question about desertification and whether this thinking, these technologies potentially, because we have so many coastal deserts, but deserts that are expanding all over the face of this planet, has applications in those ecosystems potentially as well, in terms of reclaiming desert.
Yeah, I think that desertification is a really interesting question, and I think a very simple way of answering that is that it depends on who settles the land. It's about kind of reconfiguring relationship to the land. So it's not about just throwing water or seeding it somehow or other. I think that all spaces thrive when they're properly inhabited, not just exploited, but when they're actually lived in. And there's a huge cultural dimension to that as well. I mean, so the Bedouin, for example, and their nomadic forms of existence and how they kind of relate to the land and the sky and the nature that they're in, and so kind of configure their lifestyles to those spaces. And so I think the desertification is about inhabitation, and I'm just going to look at, there was a wonderful story about a young Chinese woman who got married and had to live in the desert, and that her and her partner literally replanted, regreened the desert simply through sheer persistence. And I think that the desertification question is about hard work. That we move away from places that become difficult and try to live other. We move away from places that are difficult and try and live at places that are more kind of accommodating for our needs. But in the modern world as well, we have difficulties in the sense that we also have, kind of national infrastructures, laws, and economic systems that don't allow people to change their lifestyles, to live in a space that they call home in ways. So we're starting to see climate migrants, who's, let's say, for example, in New Orleans, where there's repeated flooding and people can't afford the insurance on their homes to be able to stay put. That kind of flooding's happening in Venice right now. The insurance system is completely different. And, there are not many poor people in Venice either. So, and the same with Florida, it's a different kind of socio-political system. So I think in one sense, the desertification question is what can we do, which is a technology-based and a materials-based question. And then the other part is the kind of the social cultural dimensions, which is, what are our tolerances, what are our expectations, and, what are the parameters that we think make, one, their life, and then two, the good life. And, what are the pressures on us that allow us to navigate both those spaces? Because I think that when land is settled, and looked after, it flourishes. It allows other life to come in. It allows transformation to come in. So when I mentioned right at the beginning the story of Pune, where the outcast people with leprosy decided they would take an unfarmable piece of land, and they literally beat the rocks down into dust and started to plant, and then they built their houses, and then they settled, and then they built their community, and then they started to trade. It's that process that's really transformed the occupancy of an uninhabitable space and turned it into something that we would call livable. We could also think into Antarctica as being the same, because Antarctica is a desert. And it's the one place in the world where there's no city. And, I would say that if Elon Musk really wants to build a city on Mars, then build the first city in Antarctica first. We will learn the lessons we need for survivability. We will have the cultural tropes. We will have the psychology that we need. That kind of extreme environment becomes livable when the tropes and the kind of customs and the needs that we have become conducive with that space. And so, yes, I think it's a really interesting question. That it's a challenge, particularly because these lands have become uninhabitable, so people have moved away, and desertification has spread because the changes are not being inhabited and dealt with as they arise. And I think that these are the big challenges that we're facing, and the kinds of living technologies that we've been talking about play a role in this. They play a role in this. They're not a solution. And I think, it's not delegating that responsibility to, people in general, but I think that we need to fight through the difficulties, that idea of prototyping the possibilities. I think it's really critical to an age of change, that we don't think we've got the solution, but we kind of work through the limits and the opportunities and try and reclaim something or claim something that's ours.
Your answer segues me into this next one, and I want to have a little fun with this. We've had several guests on the show in recent months from the National Aeronautics and Space Association in the United States, NASA. Most recently, Dr. Penelope Boston, who headed up NASA's astrobiology unit for the last few decades. And she, aside from study of astrobiology, she's a cave explorer and goes into all of these hostile environments in Antarctica and places like that to find the wonderful extremophiles that thrive so well and live very happily and go about their day. You're a a member, aside from everything else you do, you're a member of the British Interplanetary Society. Can you take us on a little journey in terms of how potentially extremophiles, so we learn about some of these species that evolution has granted these capabilities, maybe how they merge, or sort of our genetic learnings, how they may merge with protocell technologies, protocells, to go beyond this planet, or we go to do things in the deserts, to do things in Antarctica, but then ultimately to get off this planet, which doesn't involve Elon Musk nuking Mars, but potentially utilizing some of these organisms or proto-organisms to do the work for us, and that are much better at it. So I'll let you have that one and run with it. Little science fiction, science fantasy, but yeah, those creatures live here with us.
That's a really great question, because I think that, again, the idea of creating the soils before we can settle is absolutely critical to the expansion of life beyond this planet. And of course, the extremophiles and the microbes are equipped in a way with the technologies of terraforming. Again, Lynn Margulis's observation that the robustness of their biological systems transforms landscapes. It transforms worlds. We don't have 3.5 billion years, and therefore this idea of designing soils, of considering what are the stratifications of transformations that are needed in order to generate cycles of exchange. So essentially we have to tip an environment from a form of equilibrium, if there's no life, into something that's setting up the disequilibrium that Lovelock and Margulis were looking for, and make that persistence. And obviously that's catalyzed by planetary systems, and kind of whether there are magnetic fields and solar flares, and kind of an unquiet world in itself. But tipping tipping the metabolism of the space away from equilibrium, I think, is absolutely critical. And this is where this idea of designing soils comes from, and also the role of the microbiome, because you could imagine you could bacterially seed with different ecologies of bacteria, and thinking about what is the biochemical tool set that you want to release into this environment. What are the kinds of capabilities that stand a chance of tipping this system away from equilibrium, but actually a consistent review, and then adding to, and kind of a layering to keep away the forces of equilibrium from those environments. And so again, this idea of soil through position, so space and context, become really important, because we tend in science to think of things in their pure distilled forms, and we don't tend to think of them spatially and in relationship to, because those are things that we tend to control for. So I think the spatial and situational contexts, together with the types of bacteria and other extremophiles, but then also that relationship to the human microbiome and to the microbiome of terrestrial organisms, that we need to be able to find a way to re-equilibrate. That's not to homogenize, but to actually establish a condition for thriving. And if we now know that things like our mood, our digestion, fats produced on our skin are assisted by the human microbiome, then these are the kinds of organisms that we would need to find in our soils. And actually, when we look, a lot of them are. I mean, the microbiomes of our bodies and the microbiomes of the soils have certain crossovers. So I think it would be looking at the extremophiles, but actually also looking at the spectrum of livability through the customary microbes that we have in our bodies, because hopefully then that would mean that at some point that there is a compatibility between the microbial ecosystems that we've seeded and our own well-being. Without having to make this into a sterile environment where, we have to go out in, contamination suits and be really careful about what we eat.
Sure.
So yes, I think these things are choreographies. I think that they are worked into. I think they can be catalyzed, but I think it's really important that we try to get a balance between the speed that we need and the inevitable time that is taken for microbial generations to stabilize. We wouldn't really want to have a highly unstable kind of microbial environment, because that could go anywhere.
Absolutely.
So I mean, I would love to see sustained ecosystems, or let's call them like gardens. I'd love to see a space garden, and let's figure out what bacteria are needed to sustain that kind of closed world. I'm not a great fan of closed loop, because I think that you have to open that at some stage.
Okay.
But I think that you can create, let's call them tight-knit exchanges, so that there is a great deal of mutual interdependence. I think that's the condition that I'm looking for, rather than closed, because at some stage you want to kind of open things, whether that is to replenish things, or whether that is to let forms of energy in. Yes, how do we develop mutually interdependent ecosystems? And I think it needs gardening, and perhaps that is our greater role. Perhaps the role that humanity is playing is not in the colonization of worlds, but actually in the gardening, and kind of a configuring in a broader sense of the community of life. And that's something that Michael Mortner talks about, so that there's a kind of de-anthropocentrization going on there, that humans aren't the be all and end all, but they're actually they're players on a level playing field in the community of life. And I think that kind of humility of our role, I think is a good thing.
Absolutely.
Because I think it expands us. It's about expanding what it means to be human, rather than constraining it more as a particular kind of thing. And I think that kind of ability for us to interrelate and be infused by other influences will ultimately make us more robust. Even if, in 250 years, we might look back at the forms that we're taking today and go, oh my gosh, I don't really recognize myself in that form. There's something really weird about them. But I think that kind of capacity to assimilate and be infused by and transform, I think is the condition for survival in extreme conditions. And I think that we've obviously seen that in the story of Earth, where the primordial beings, the archaea and the bacteria, through their kinds of interminglings, become the eukaryotes, and then the eukaryotes become intermingled with their ancestors, and the symbiogenetic stories that we're now seeing through reading DNA and kind of the studies of molecular biology, I think are really interesting, because I think what they're doing is helping us understand how we may survive hostile environments and extreme conditions, and it's giving us some clues as to how livability can be achieved.
One other question along those lines, with this perspective of us, Homo sapiens, as we sit here, not being the be all end all, but you wrote co-authored a paper a few years ago, a fascinating paper entitled "On the Creativity of Slime Mold," where you conclude we propose that the building blocks of creativity in a dynamic system without a formal nervous system can be considered via external relationships with morphological meaning. It's a fascinating paper. It reminded me of another that I read a few years ago on cognitive bacteria, behavior, and all of this sort of non-hierarchical dynamics that occur in bacteria cultures in terms of sensing and perception and balance and all of these other things that we normally just think about from the perspective of us. Take us into the world, your views, your concepts on, as this paper, talks about intelligence in nature, there's many creatures on this planet that do not possess nervous systems. They don't possess brains, a la slime molds, bacteria, yet they function and they do things as groups, interacting, communicating. Take us a little out into this world of intelligence in nature and sort of in the future context of these living architectures, living machines. What does that mean in terms of sort of other forms of intelligence that we may be creating beyond our own?
This is a really great question, because I think the idea of an interiorized thought and interiorized intelligence is a really, it's an Enlightenment trope. And it's one that we've internalized through the discovery that we have a brain, and scientific findings that show relationships between electrical activity and thinking. Yep. And our own kind of philosophical and psychological understanding of ourself. And let's say for a moment that actually this is a function actually of our biology. The function of the way that that we see ourselves and that we understand things, because we are this particular kind of thing, and that kind of works for us. When we have different bodies and when we have different ways of perceiving the world with different kinds of senses, from the unicellular that is looking for pH changes in the environment and has a kind of a tactical relationship with that stimulus. The idea of where meaning lies, what it is that we respond to, actually becomes quite interesting and diverse. And so that one wonders, and you cannot possibly know, but the idea that meaning may be outside of a being whose experience is at its interface, right? So that, yes, it's got a nucleus, and that nucleus does a lot of processing of its metabolism, and it allows it to produce energy and live. But actually, the things that it needs to pay attention to are not on the inside, they're on the outside. And so that, potentially one could start to imagine that meaning is outside the membrane. Its actions then get transferred almost, internally and interiorized and turned into forms of action. But the meaning itself is outside. Now, that doesn't mean that it always has to stay outside. It could actually come inside and is translated as a material thing. So that so the question that is related to that then is, if experience and meaning is outside, is that purely abstractional, or is that actually something physical? Which is also quite interesting if one thinks about photons as being physical, rather than something that stimulates a particular kind of psychology. And so if we think about that, if meaning can actually be a physical thing, because we're actually responding to something real, and that the patterns of behavior that are derived from that actually become, first of all, characteristic of your being, and then maybe socialized and culturalized in some ways through community. So, formation of biofilms, and the surveillance of biofilms to make sure that cheetahs don't survive. Those kinds of social forms of socialization in the non-human realm. So someone, Myra Hurd was a sociologist who worked with Lynn Margulis in her lab. And she came up with this book called The Origins of Sociable Life. And so what she was doing was reading the bacterial realm through the lens of a sociologist. Now, I'm not sure, you can go, that's just anthropocentrizing everything. But it's very interesting as to how she starts to strip away parallels as to how we start to create narratives and explain causality, and how some of the things that we perceive as being sociable can be demonstrated in bacteria. So that actually helps you start to think inside the possibility of others, and that just because we have a certain human kind of way of thinking and responding and relating, and we enjoy it, we love it, we esteem it, that doesn't mean that other organisms don't have an equally rewarding system of relating to the environment and to each other. And I think where this comes into the Living Architecture project is, I think, at the biodigital interface. So we can think of life as being the uninterrupted flow of electrons between atoms and bodies. So that as long as electrons are flowing and, kind of physical circuits are kept away from equilibrium through that electron flow. So Jim McFarlane, for example, is one of a chemist who would kind of entertain that idea. So if we think of the perpetual flow of electrons, this idea of biodigital interface kind of becomes very interesting, because if electrons are hopping over from what we would call an electronic circuit or a robot or a machine in some ways, and actually has meaning and can be interpreted by a biological system as a very direct thing and not through symbolic representation, then actually you're getting the coming together of bodies like a holobiont, a kind of an ecological, mutually sustaining community. And Donna Haraway would describe that as a cyborg. Although I think that her interpretation is still quite anthropocentric. I think it was a great departure to start to say that actually collaborations between different kinds of bodies from different ontological origins can actually form collectives that seem to be a body in themselves and actually have a coherent narrative as a group. So I think that the Living Architecture project, we're developing a biodigital interface in the ALICE project, which is essentially sensors that are looking at the feelings and the doings of the bacterial biofilms, and is accessing different kinds of animations. So it will tell you how the pH is doing, or the temperature, or the amount of phosphate in the urine, and that will give you different pictures. Now, it means, though, that there's a synergy between the electronic circuits and the biological systems, the excreta coming from the biofilms that are producing the electrons that become the electrical currents, so that they are kind of bodily interrelated. And so I think that this, so the question becomes, where is intelligence in that system, given that the electronic display is designed, but there's actually some real transactions between the microbes and the electronic systems. They're not bidirectional at the moment, but it would be great to be able to, think about what the electronic system gives back to the biological systems. At the moment, it'd be actuators that would try and help increase the pH if it's too acidic, so it would be actuator to do that. But if the electronic interface could actually create mutual exchange, that becomes very interesting in terms of what constitutes a body in this context. So I think that this idea of intelligences, I think has, I think it's very cultural. I think that there is a philosophy that underpins it, but I think that we should at least create the space for thinking through what it means to exchange matter that can cause action and acquire information from systems. And I think that life has created a plethora of ways of doing that. So I think I think it's naive to think that there's only one kind of intelligence. And I think that we can possibly learn a lot by paying attention to how different forms of bodies interact with each other in sustained and close loops of information exchange. And I wouldn't just reduce it down to information exchange, because I think information becomes a bit too disembodied at some stage. And you know, I'm a materialist in the sense that I'm a new materialist. In that you know, matter is at the heart of everything, but it's not inert.
Right.
Matter is fundamentally lively. You know, Einstein's notion that, you know, quantum physics changed everything except the way we think. So can we actually start to think into matter, you know, understanding that no matter is still, all matter is doing something.
Sure.
You know, even if that's just a little bit. So I think that there is a material underpinning for what we call intelligence, and I think that as we start to apply our discoveries of the 21st century in new ways, I think we'll start to see patterns emerging that we couldn't see before. And I think the example of that would be with the advent of the DNA technologies that are now showing us that this simple story that we had of the, you know, nucleus governing everything, you know, through instructing code from DNA into the cytoplasm, you know, is much more sophisticated than that. And I think that we'll start seeing the same thing about intelligence. I don't have the answer to it, but I think that if we hold the space open, I think that creating these synergies, bringing things into proximity and observing, you know, the attractions and repulsions and things that get sustained, I think that we'll learn an awful lot about the living world in its kind of more holistic kind of context.
You know, it's Rachel, it's been such a pleasure, Donna, listening to you to talk. I mean, your thoughts, your ideas, your strategy for making this world a better place. It's just, I take my hat off to you. It's eye-opening, and it's just, once again, it's been a real honor having you. Before we log off, I just wanted to once again give you the floor. If there are any folks that you want to shout out to, any influencers over the course of your career, plug the Living Architecture Project again, but please, once again, for everybody that's going to be watching on the YouTube channel, listening on the various podcasts, Professor Rachel Armstrong, Newcastle University, director and founder of the Experimental Architecture Group, coordinator of the Living Architecture Project. Rachel, take us out, and once again, thank you for being here, but I'll give you the floor for last messages and anything else you want to say, because it's been fascinating.
Yeah, well, thank you ever so much for the invitation. It's been great fun being able to indulge myself in you know, a conversation like this, and absolutely huge thank you to the Living Architecture Project, to University of Trento, to University of West of England, Spanish National Research Council, Liquid Systems Group, Explorer Biotech, and the European Union for you know, being so bold to support out there ideas, and you know, kind of giving us the opportunity to be able to go into this adventure. Also to Translating Nature, who are on our Alice project, and to everybody who's contributed to the Mu project, and also the mentors that I've had, you know, with Living Architecture, and you know, people like Neil Spiller and Martin Hanser and Steen Rasmussen. I mean, really, you know, creating a space for me to be able to you know, explore what are not conventional ideas in you know, very stimulating and creative environments, you know, has been, you know, absolutely transformational. So big shout out to all of those, and you know, everybody that you know, has helped and supported me along the way, and all my collaborators. I mean, I really think the world of you, and I've had the most amazing collaborations.
Outstanding. Professor Rachel Armstrong, thank you so much for your time today. It's been a real honor.